Hi students, let us study the first chapter that is called the solid states. Okay, so in solids we are going to study the first of matter. So what is matter? Matter is anything which occupies space on earth and have some mass. Okay, so this is called matter. So depending upon the physical state of matter, matter has been classified into three categories. The first one is called solid. And the second one is called the liquid, and the third one is called the gas. Okay, so first we will study about the solids. So what is a solid? Substance which is having a definite shape and definite volume. That means this substance is having a definite shape and also having a definite volume. So in these solids, there will be particles. There will be particles. Those particles are closely arranged. In between the particles, there is no gap between the particles. Okay, that means the force of attraction between the particles is very, very high. Okay, so and in case of solids, the particles either they are arranged in a orderly manner or disorderly manner. So depending upon the arrangement of particles in case of solids, solids has been classified into two categories. That is, solids are classified into two categories depending upon the arrangement of particles. That is, crystalline solid and amorphous solid. Okay, so solids depending upon the arrangement of particles, we can classify the solids into two categories, is crystalline solid and also amorphous solid. Then what is a crystalline solid? So crystalline solid is nothing but one of the type of solid in which the particles are arranged in a orderly manner. Okay, so in case of amorphous solids, the particles are arranged in a disorderly manner like this. That is not in an orderly manner. So the arrangement of particles will be in a zigzag manner or disorderly manner in case of amorphous solids. So what are crystalline solids and what are amorphous solids? So crystalline solids are nothing but the type of solids in which the particles are arranged in a orderly manner. Okay, so what are amorphous solids? Amorphous solids are also the type of solids in which the particles are arranged in disorderly manner. Okay, next we will go through the differences between the crystalline solids and amorphous solids. Come to this. Okay, so crystalline solid and amorphous solids can be classified in this way. Okay, so in case of crystalline solids, the particles are arranged in an orderly manner. Orderly means there is an orderly arrangement of particles on this. Okay, so in case of amorphous solids, the particles are arranged in disorderly manner. That means the arrangement of particles are in a disorderly manner like this. Okay, so due to the orderly arrangement of particles, crystalline solids are having a regular geometry. The shape of crystalline solids is nothing but a regular shape. So the regular geometry is due to the orderly arrangement of particles in case of crystalline solids. Okay, next coming to the amorphous solids. Amorphous solids are having irregular shape or irregular geometry. So the irregular shape of amorphous solids is due to the irregular arrangement of the particles. Okay, next coming to another type of difference between the crystalline and amorphous solids is crystalline solids are anisotropic in nature. So what is meant by this anisotropy? So we will explain the anisotropy of crystalline solids by taking one of the example. Let us take NaCl. NaCl is nothing but one of the example for the crystalline solid. So we will take Na plus ion as a small sphere and a large sphere having much radius is Cl minus. So we will arrange these particles like this. also in a different manner like this. So there is no arrangement of particles that is Na plus, two Na plus ions are not directly linked with one another, and also two Cl minus ions are also not directly linked with one another. So alternate particles of Na plus and Cl minus ions will be present in this. Okay. So if we calculate the physical constants like thermal conductivity or electrical conductivity and also refractive index like that in different directions through this crystalline solids like this. So we will go through this line or this way and we will calculate the value of thermal conductivity and also electrical conductivity or a refractive index along this direction. So the value of these physical constants are having some value, that is T1, E1 and R. So if we calculate the same values of these physical constants in the other direction like this. So the values of these physical constants will be different in different directions. So this is the first direction and this is second direction. So the values of these physical constants are different from first direction to second direction. So what is the reason for the difference between the physical constants in the two different directions? That is, in the first direction there is a presence of both Cl minus ion and also Na plus ions. Both cations and anions are also present in the first direction. In case of second direction, there is a presence of only one kind of ion. So due to the arrangement of particles which are different in different directions, the values of thermal conductivity, electrical conductivity and also the refractive index values will vary from position to position. That means they are not same in all directions, they are different in different directions. So since the values of physical constants are different in different directions in case of crystalline solids, hence the crystalline solids are anisotropic in nature. And coming to the amorphous solids are isotropic in nature. Why amorphous solids are isotropic in nature? Let us study the arrangement of particles in case of amorphous solids. So the arrangement of particles will be in this way. That means irregularly arrangement of particles will be there in case of amorphous solids. So if we calculate the physical constants like thermal conductivity or electrical conductivity or refractive index, so the values of all those physical quantities will remain almost equal in different directions. So because of almost having the same value of physical constants in other directions, hence we can say amorphous solids are isotropic in nature. So crystalline solids are anisotropic in nature, whereas amorphous solids are isotropic in nature. So why crystalline solids are anisotropic in nature? Because the values of physical constants are different in different directions because of orderly arrangement of particles. In the different directions, there is no arrangement of particles equally in all the directions. So because of that reason, crystalline solids are anisotropic in nature, and in case of amorphous solids are isotropic in nature because in case of amorphous solids, there is an irregular arrangement of particles. If we go through different directions, almost the number of particles in all the directions will be one and the same, almost one and the same. Hence, if we calculate the value of physical constants through this amorphous solid in different directions, they will be one and the same. So almost they will be one and the same. Hence, the amorphous solids are isotropic in nature. And we will go for some other differences between crystal and amorphous solids. So crystalline solids shine in presence of light. That means we know NaCl, that means the common salt. So if we allow a light to fall on the crystalline solid NaCl crystal, that gets shine. That means the light gets shine in presence of the crystalline solid gets shines in presence of light. So the particles gets shined by the application of the light above the crystal. That means the crystalline solids shine in presence of light, whereas amorphous solids do not shine in presence of light. So what's the reason? Because amorphous solids are not having definite shape, and even the crystals, we cannot identify the crystal particle also in case of amorphous solids. So if we allow a light to fall on the amorphous solid particle, so that particle will not shine in presence of light. Okay, so hence we can say crystalline solids shine in presence of light and amorphous solids do not shine in presence of light. Next, coming to the another difference. So crystalline solids are having sharp melting point. So what is meant by melting point? Melting point is nothing but the temperature at which the solids undergoes liquefaction. So solid is converted to liquid. The temperature at that point can be taken as melting point. So coming to the crystalline solids, crystalline solids are having sharp melting point. What is the meaning of that? So sharp melting point means, so these crystalline solids, they will undergo liquefaction suddenly. That means solid is converted to liquid suddenly. In a fraction of seconds, the liquefaction of that solid will undergo. That takes place suddenly. Okay, so in case of the amorphous solids, the melting point of amorphous solids is having some range. That means the amorphous solid particle will undergo softening first and then undergo liquefaction. So it takes some time. Take some range so that we can say that amorphous solids are having a range of melting point and the crystalline solids are having a short melting point. And then the examples for this type of different types of solids, that is crystalline and amorphous solids, are for the crystalline solids, the example is NaCl, that is sodium chloride, cesium chloride, zinc sulfide, KCl, potassium chloride, etc. So these are nothing but the examples for crystalline solids. And for the amorphous solids, wood is one of the amorphous solid in which the particles are at irregular number. Plastic is also one of the amorphous solid. Rubber is also one of the amorphous solid. Okay, so this is nothing but the differences between the crystalline and amorphous solids. Next, coming to the types of crystalline solids. So what are the types of crystalline solids? So depending upon types of crystalline solids. So there were 4 different types of crystalline solids. They are, the first one is ionic crystalline solid, and then the second one is covalent crystalline solid, and then the third one is metallic crystalline solid, and then the fourth one is molecular crystalline solid. So let us study one by one. What is ionic crystalline solid, what is a covalent crystalline solid, and what is a metallic crystalline solid, and what is molecular crystalline solid. Okay. So first we will go through the ionic crystalline solid. So what is ionic crystalline solid? This is nothing but one type of crystalline solid in which the particles can be taken as the ions. That means in between the ions, it may be either cation or anion. So in between the ions, there is some force of attraction. So that force of attraction can be taken as the ionic bond. Okay. So in between the ions, there is a presence of ionic bond. So in any kind of crystalline solid, if ionic bond will exist between the particles, so that type of crystalline substance or crystalline solid can be taken as ionic crystalline solid. So example for ionic crystalline solid is NaCl, KCl, etc. Okay, so ionic crystalline solid is nothing but a type of crystalline solid in which ionic bond will exist between the particles. So that type of solid can be taken as ionic crystalline solid. Example is NaCl, KCl. Okay, so here observe here NaCl. In between these two there is a presence of ionic bond. And also, in case of KCl, there is a presence of ionic bond. So, this is nothing but the ionic crystalline solid. Next, coming to the covalent crystalline solid. So, what is a covalent crystalline solid? So, a crystalline solid in which the covalent bond will exist between the particles. That means, in between the particles.